Okay, here we go with question 5. First of all, it asks you if you've got a sample which you believe is that compound, but you want to make sure how you could check that out without using spectroscopy. So the key to this is to recognise that it's an aldehyde, and that with aldehydes or ketones you can react them with 2,4-dinitrophenylhydrazine, and that provides you a method of identification. So the trick is, remember, for any aldehyde or a ketone, if you want to verify that it's a particular one, you first of all react it with 2,4-dinitrophenylhydrazine. You need to make sure you know that word. They won't accept abbreviations. When you add it, you get an orange precipitate. You then have to purify that by recrystallization. And again, don't just say purify, you've got to say how. Purify by recrystallization. And then you find its melting point. Not boiling point, melting point. And you compare it with published values, because there are tables out there and you can look up if it's 176 degrees, you can say, yeah, that's that one, whatever it was. Okay, so react with 2,4-dinitrophenylhydrazine, recrystallize to purify, find the melting point, compare with published values. Okay, now we've got to find a method to convert this into that. So obviously we've got two functional groups to change, two-stage reaction. You can pretty much do it in either order. So I'm going to start by converting the aldehyde group into the carboxylic acid group. So we're going to go through an intermediate compound, which is this one, still with the NO2, but now with COOH there. So that's obviously just an oxidation, and you can do that using aqueous acidic potassium dichromate. Okay, standard thing for oxidizing alcohols, but also for oxidizing aldehydes to carboxylic acids. Aqueous acidic potassium dichromate, and you want to reflux that to make sure that you get the reaction to go to completion. The equation for that is very easy. As with all oxidations, you just use the magic oxygen to represent the oxidizing agent. So it's just that plus magic oxygen goes to that. You could also use Tollen's reagent and heat it with that, and in principle the same reaction occurs. You don't normally use that for preparative things, but you could do, and that would be fine. Okay, now we've got to convert this compound to that one. In other words, we've got to reduce the nitro group to NH2. So let's have a look at how we can do that. With reductions in organic chemistry, there are different reagents for different reductions, and they're not interchangeable. So if you thought of NaBH4, that is a reducing agent, but that's the one you use for reducing carbonyl groups to alcohol groups. Doesn't work for this. What you need for this one is tin and concentrated hydrochloric acid, and again reflux. Okay, tin and concentrated hydrochloric acid is a powerful reducing agent. It will convert that NO2 to NH2. What you should remember is that because it's under acid conditions, what you'll actually get in that reaction is the salt with NH3 plus and Cl minus there. So what you actually have to do is first that, the tin and HCl thing, and then neutralise, which you could do just with sodium hydroxide, aqueous sodium hydroxide. Because if you don't do that, then strictly speaking it doesn't produce this, it produces the salt. So two stages there, tin and conc HCl reflux to do the reduction, and then neutralise with aqueous sodium hydroxide. So the overall change, we won't bother putting the sodium hydroxide in the equation, is just that compound plus 6 magic hydrogens are needed there, because you've got to get rid of those 2 oxygens and put 2 hydrogens in. You get that lot plus 2 waters is your overall change. And that's it for this paper. Okay, so I hope that was valuable. I would welcome any feedback. I might do another one, but it depends on all kinds of things, like whether everybody thought this was rubbish. Okay, so that's it. enjoy your exam.